Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 2 of 5 good problems on the chapter of direct and inverse variation. If you have not watched the set 1 where I solved the first set of 5 good problems on this chapter, then I highly suggest and request that you please also watch that video. So this video is part of the playlist Maths 8 Hot HOT. Hot HOT stands for High Order Thinking High Order Thinking, where I come up with relatively harder problems compared to the problems that I solve in the other playlist, that is CBSE Maths 8 R.S. Agarwal from the textbook of author R.S. Agarwal. Uh, if you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time, or this is the first video you are watching, and if this video is beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the set 2 of 5 good problems on the chapter of direct and inverse variation. Okay, so I have the problems, 5 good problems on the left hand side. These are numbered 6 to 10 because I originally prepared 10 good problems for making a video of 10 good problems, but now I'm making 5 good problems to make the video shorter. Uh, but I will keep on making sets of 5 good problems. Uh, I will keep on making more sets of 5 good problems from every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 R.S. Agarwal. Okay, so let's start solving the problems. Even though I am the questions are sorry, even though the questions are numbered in the PDF problem set 6 to 10, I will number them 1 to 5. Okay, question number 1 says a certain number of squares are arranged to form a rectangle of dimension p centimeter by q centimeter. If we want to have a rectangle of length L centimeter, then what will be the breadth? Okay, a certain number of squares are arranged to form a rectangle of dimension p centimeter by q centimeter. So the rectangle, let's say this is the rectangle formed by a certain number of squares. We don't know the number of squares. Roughly I'm drawing, let's say these are the squares, and let's say this is p centimeter, this is the length, and let's say this is q centimeter. Now, so the number of squares, please, the concept to understand in this problem is that the number of squares are fixed. Using that fixed number of squares, we have to make the rectangles of different length and width. So clearly, when it is saying that a rectangle of dimension p centimeter by q centimeter can be arranged by a certain number of squares, we know for certain that the area of any triangle, we can say that area of any triangle, area of any not triangle, sorry, area of any rectangle, area of any rectangle, area of any rectangle formed by the squares is fixed, which is p multiplied by q, this much square centimeter, because this will be the area pq square centimeter will be the area of any rectangle that you can form using the squares. So these are the squares, the small tiles of the squares. Now it is asking if you want to have a rectangle of length L centimeter, then what will be the breadth? So clearly we can see that if the area, so we have to find the width or breadth of a rectangle having length L centimeter using these squares. Okay. Now we have a fixed number of squares whose if we arrange them in a shape of a rectangle, the area will be PQ square centimeter. So if you consider the two quantities x, let's say x to be the length of rectangle, and of course this will be in centimeter, and y to be the width of rectangle in centimeter, then clearly we are having, since the area, if we want to keep the area fixed, we must have x must vary inversely with y, or you can say you can also write in the opposite direction, like y varies inversely as x, that is y varies inversely as x, or x varies inversely as y. Because if the area is fixed, if you can understand from common sense that if the area is fixed, if you increase the length, the breadth has to decrease, and if you decrease the length, the breadth has to increase. So and we know that when two quantities are vary inversely with each other, there the product of them is a constant. So we have xy is a constant, which is known as this constant is known as constant of variation or proportion. So now we can quickly create a table xy. It is already given that when the length, the squares, whatever number of squares is available, that squares can form a rectangle of length p centimeter and width q centimeter. So we can have a data q and p, that is the corresponding values of x and y. Now it is asking if we want to have a rectangle of length L centimeter, length is L centimeter, so L, and what will be the breadth. So let's say let width or breadth be y1, since the quantity y represents the width of the rectangle. Let width be y1 when length is L, that is L centimeter, and let width be y1 centimeter. So we can add these corresponding values in the table. We have y1. Now we have to solve for y1. So we know that xy is a constant, that is the product of the corresponding values of these two quantities should be a constant. So we must have p multiplied by q should be equal to L multiplied by y1. This implies y1 is equal to p multiplied by q divided by L, which is pq by L centimeter. So pq by L centimeter should be the width of the rectangle whose length is L, that can be formed from the squares. So the correct choice is D. D is the correct choice. So after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Okay, let's solve the next problem. Question number 2, which is actually question number 6 on the PDF. Question number 7. It is given that 2x plus 7y divided by what is given. Let's write down the given equation. 2x plus 7y divided by 2x minus y is equal to 3. This is given. Then which of the following option is correct regarding the two quantities x and y? Okay, so x and y must be two quantities. They must be related to each other, that is they must vary with each other, and an equation relating how x and y are related is given in the form of this equation, and from this we have to say whether the choices are, if you see the choices, the choices are mentioning whether x is varying directly with y, or x and y varies directly or inversely, and the constant of proportion. K is denoted as the constant of proportion or variation of two quantities x and y if they vary with each other. So we have to find whether x and y varies directly or inversely and the constant of proportion. Okay. Now, if we want to, if the quantities x and y, if indeed quantities x and y varies directly with each other, we know that x by y will be a constant. X by y will be a constant. Now, so if indeed x and y varies directly, from the given equation we must find the value of x by y as a constant. If we can, then we can clearly say that x varies directly with y, and we can and the value of x by y will be the constant of proportion. Now, if it is the other way around, and if indeed the two quantities x and y varies inversely with each other, we must have something like x varies inversely with y, that is this, and this will imply that x, their product, will be a constant. So from the given equation, if we can find the value of xy as a constant, then we can say that the quantities x and y will vary inversely. Now let's see uh, which one of these two is true. We have to find which one of these two is true. Okay. Now, from the given equation, if you observe, if you divide, now remember that in these problems of direct and inverse proportion, the quantities x and y, they are never zero. They are never zero. So if I divide the left hand side, LHS, both the numerator and the denominator by y, what do I get? Dividing, this is pure by observation. Dividing, because if I divide by y, I will get the expression x by y. So dividing both numerator and denominator of LHS by y, we get, let's do it step by step. So I am dividing both the numerator and the denominator by y. So this is what we are doing. We can do this. So the LHS is a rational term, even though the numerator and the denominator both are having some variables, x and y you can consider as variables, but it is in the form of a rational term, that is p by q. And we know that in rational number we can always divide or multiply both the numerator and the denominator by some non-zero number. Okay, so we have this is equal to 3. Now this will imply, if we simplify the LHS, what do we get? We get 2 x by y plus 7y by y divided by, you can use some brackets for better readability, and I have over here 2x by y minus y by y, this. I have just splitted both the numerator and the denominator. I have splitted the numerator with the plus and the denominator with the minus. Now if I further simplify, I get 2x 2 into x by y minus 7y divided by y is 7 plus 7 divided by 2x 2x by y minus y by y is 1 is equal to 3. Now from here, as you can see, I can find the value of x by y. I can clearly find, you can consider the x by y as some another variable z. So let's say uh, let's not use another variable to make it more complicated. We can solve it like this only. So we have, if we do cross multiplication, we have 2 x by y plus 7 is equal to 3 multiplied by twice of x by y minus 1. So this implies we are trying to solve, we are trying to find the value of x by y. Considering in your mind you can consider the x by y as another variable. So we have 7 is equal to, if I simplify, open the brackets on the right hand side, I get 6 x by y minus 3. Now we get bringing the, you can bring the x by y terms to the right hand side and all the constants to the left hand side. I get 7 plus 3 is equal to 6 x by y minus twice x by y. So this implies 10 is equal to 4 x by y. So this implies x by y will be equal to 10 by 4, which is equal to 5 by 2. So x by y is equal to 5 by 2, and indeed we have found the value of x by y to be a constant. So clearly we can say that x varies. This implies x varies directly as x and y varies directly, and the constant of proportion is equal to 5 by 2. So hence the correct choice is D. Now from the given equation, it should be very obvious that you should from observation you should understand that we can clearly find the value of x by y or even y by x. If I would have divided the numerator and the denominator of the LHS by x, then I would have got 2 plus 7 into y by x divided by 2 minus y by x, and I could have found the value of y by x, and that would have been a constant, and so we can say that x and y varies directly. Okay, let's solve the next problem. Question number 3. Which of the following vary directly with each other? Which of the following vary directly with each other? A, let's see all the choices. A is distance covered and train fare. Distance covered and train fare. So if you consider D as distance covered by train, and let's say the fare F be fare of the train, fare of the train journey. That is, if you are traveling by train, obviously if you are traveling for a longer distance, the fare will be more, and if you are traveling for a shorter distance, the fare will be less. So clearly we can say that the fare will be directly proportional to D. The more the distance we travel by train, the fare will be more. Okay, so definitely choice A varies, the quantities, distance covered and the train fare varies directly with each other. Let's see choice B. Distance covered and time taken when speed is constant. Okay, so at constant speed, we have already solved a problem on this based on uniform speed or constant speed and the quantities, distance covered and time taken. So at constant speed, uh, at constant speed, if you consider the quantities, distance covered, let's say distance covered, d be the quantity, distance covered, uh, and time t be the time taken. We know that if the vehicle is moving at constant speed, with more time, it will cover a longer distance, and with less time, it will cover a shorter distance. So clearly, we can say that the distance covered will be directly proportional to t, or we can say that the quantities d and t, that is distance covered and time taken, will be directly proportional to each other. Okay, let's see choice C. Number of days worked and money earned. So, okay, number of days worked. Let's say N is number. Now, this is based on workers. So, workers work on daily basis. So they have a daily wage, and so per day they get some fixed amount of wage, and so definitely if they work for more days, the wage will be more. The number of days work, if n denotes the quantity number of days worked, and money earned, payment p is the money earned, which is also you can consider as payment, or you can consider as wage. These three all means the same thing. So definitely we can say that the payment will be will vary directly with the number of days worked, because usually for workers there is a fixed rate. I mean it could vary from now a type of workers, but for a certain type of workers they charge a fixed amount of money per day. So if they are working for one day, let's say their wage is 200 rupees, and if they work for 100 days, definitely it will be 200 multiplied by 100 rupees. So clearly P and N varies, these two quantities varies directly with each other. Okay, so clearly we can see that the choice, so all the choices A, B, C are, the quantities mentioned in the choices A, B and C are all varying directly with each other. So the correct choice will be D, that is all of the above. Okay, let's see question number 9. This will be question number 4 for this set. Both x and y vary inversely with each other. When x is 10, y is 6. Both x and y vary inversely with each other. So we can say that x is varying inversely with y, and so this will be x varies inversely with y. So we write it as this. Now, one thing I would like to mention, that in the previous video when I was solving set 1 problems, I accidentally said that when I was saying when I was discussing about a problem regarding two quantities being two quantities being in inverse variation, so let's say if the quantities x and y, they vary inversely with each other, we write it as this. Now I accidentally said that x varies inversely as 1 by y. No, x varies inversely with y, and this is how we write it in mathematical notation. This does not mean x varies inversely with 1 by y. No, that is very, very incorrect. X varies inversely with y, and this is x varies directly with y. Okay. So in this problem, it is given both x and y vary inversely with each other. So we have x varies inversely with y. So we write this. Now when x is 10, y is 6. Which of the following is not a possible pair of corresponding values of x and y? Now we know that when two quantities x and y vary inversely with each other, we must have the product of them will be a constant. That is, if we consider corresponding values, the product of all the corresponding values will be a same constant value. And the constant value is known as the constant of proportion, constant of variation or proportion. Now we need to check. So it is asking which of the following is not a possible pair of corresponding values of x and y. Okay. So if you just create a table x and y, one set of corresponding values is given is that when x is 10, y is 6. Y is 6. So this clearly says that the constant of proportion or variation k is equal to 10 into 6, which is equal to 60. K must be 60. Now we need to select the choice for which the product of the corresponding values is not equal to 60. So A 12 into 5 is 60, B 15 into 4 is 60, C 23 into 24 is certainly not equals to 60, and definitely D 45 multiplied by 1.3, I guess this is also then which of the following is not a possible pair of corresponding values of x and y? What is this? 45 and 1.3. Now the only one choice should be correct. So I was hoping that choice C will be the correct answer, because 23 multiplied by 24 is not coming equal to 60. So this pair 23 and 24 is not a possible pair of corresponding values, based on the fact that when x is 10, y is 60. In that case, based on that, we must have the constant of variation must be equal to 10 into 6, that is 60. A is okay. A 12 comma 5 is a valid corresponding values. Also for choice B, 15 and 4 is also correct corresponding values. C is not, and 45 and choice D 45 into, I am just using a calculator, sorry for this. What is 45 multiplied by 1.3? It is 58.5. This is 58.5, and definitely this is also not equal to 6. So ideally, as per the given problem, choice C and D should be the answer, but I think accidentally I gave the wrong choices. Only one choice should be correct. Anyway, so for this problem, the correct choice should be C and D. So the pairs C and D, that is 23 and 24, these corresponding values is not a possible pair, and also 45 and 1.3, these corresponding values is also not a possible pair. So we have two choices as correct. Okay, let's do the last problem. If 15 boys can make 40 charts, if 15 boys can make 40 charts in a day for their annual project, how many more boys are needed to make 120 more charts in a day? If 15 boys, so whenever you solve problems on direct and inverse proportion, the first thing you have to identify is the quantity. Which are the two quantities that you need to focus or use to solve the problem. So, so it is talking about the number of boys and the number of charts they are making in a day. As you can see, this is a kind of time and work. The time is fixed, that is 1 day, and the work is how many charts they are making, and of course there are number of boys. So when the time is fixed, so if we consider the quantity x as number of boys and y to be number of charts prepared by the boys. Now, if the time is fixed, that is in 1 day, if there are more number of boys, definitely they will make more number of charts, and if there are less number of boys, they will make less number of charts, since the time is fixed. So clearly we can say that the quantities x and y varies directly with each other. Okay, now it is given one set of, if we try to create a table of x and y, the first corresponding values is given as, if 15 boys can make 40 charts in a day. So 15 boys, we enter the corresponding values in the table, 15 and 40. Now it is asking how many more boys are needed to make 120 more charts in a day. So let's x1. Now whenever, please remember that whenever you are assuming some unknown quantity, unknown value of the quantity x, always use the variable x1 or x2 or x3. Similarly, whenever you are using some unknown, you are assuming some variable to represent the value of the quantity y, then use the use the naming convention of y1, y2, y3, etc. So let x1 more students, more boys is required to make 120 more charts. We are assuming this. We are assuming let's say x1 more boys is required to make 120 more charts. So this will imply that x1 more boys means 15 plus x1. It means that 15 plus x1 boys will make 120 more charts, 120 more than 40. So 40 plus 120, that is 160 charts. Now I can enter these two corresponding values in the table. So I can write 15 plus x1 and y as 160. Now since these two quantities x and y are in direct proportion, we must have the ratio of the value of the ratio. The value of the ratio of all the corresponding values must be the same constant. So we must have 15 by 40 is equal to 15 plus x1 divided by 160. So we get a linear equation in the unknown x1, and we can easily solve it using the technique of solving linear equation in one variable. Now before doing cross multiplication, always try to simplify the values. That is, if you can divide, you can if you can divide both the sides by some number or multiply with some non-zero number. Now first of all, I can cancel out the 0 from both the denominator, and then I can cancel out I can divide. I can cancel 40 and 160 and will have 44 over here. So basically what I did is, if I divide 15 by 40, the equation 15 by 40 is equal to 15 plus x1 by 160. If I multiply both these equation by 160, we get So let's do that way instead of cancelling. This is not a correct way of solving the problem. What instead we should do is we are multiplying both the LHS and RHS by 160. Why? Because both the LHS and RHS are in the rational form, and the denominators of the LHS is 40 and the denominator of the RHS is 160, and the LCM of 40 and 160 is 160. So whenever we have this kind of equation, if you I have already completed the chapter linear equations in one variable in the same playlist, not in this playlist, sorry, in the other playlist, that is CBSE Maths 8 or Agarwal. If you need to have a good understanding and practice of good problems, you can watch those videos in the other playlist. And I have also done quite a few 10 good problems on that chapter, that is linear equations in one variable. So whenever we have a linear equation of this type where some or few terms either on the LHS or on the RHS are in the form of rational terms, we find the LCM of all the denominators of the rational terms and we multiply both the LHS and RHS by that LCM, which is what we are doing in this problem. We are multiplying both the LHS and RHS by 160, where 160 is the LCM of 40 and 160. So this will become 15 multiplied by 4 is equal to 15 plus x1. So this implies 60 is equal to 15 plus x1. This implies x1 is equal to 60 minus 15, which is 45. So what was x1? x1 was, as per our assumption, more boys required to make 120 more charts. So we need 45 more boys, and then 15 plus 45, that is 60 boys can make 120 more charts. So the correct choice is D. D is the correct choice. So with this, I come to an end in solving 5 good problems on the chapter of direct and inverse variation. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will keep on preparing and solving this kind of 5 good problems on this chapter in the future, so please keep an eye on this playlist. And also very soon I will be starting the next chapter, theoretical chapter from the textbook of author R.S. Agarwal, which is on polygons in the playlist CBSE Maths 8 R.S. Agarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.